So the owner dropped off the 1985 Olds 98 for a few days, and we're going to go to town in this thing. So I already got the engine computer out of its home under the dash just to do a quick visual inspection. Old electronics, if you can take it apart, definitely inspect for leaky capacitors, cracked solder joints. This unit looks absolutely mint. No blown caps or cracked joints that I could see. There's the original part number. So just a quick visual inspection. Before going on any more test drives, I want to tension the power steering and AC belts. They are extremely loose, like flopping around, literally flopping around. That's why the power steering was squealing. Same with the AC. Maybe take apart that caliper so the brakes aren't dragging. And then we can get to diagnosing this fall on its face above half throttle issue. So we can do all the checks right here at the ECM. Very convenient. We hook up the scope, sit on the couch, and do our measurements during the test drive. Now on the PCM connectors, I see some really weird brown goop. I don't know what the heck this stuff is. Kind of looks like poop. Doesn't smell like poop. It's not really, all over the place, but I want to wipe that off. Plug this thing back in, and then we can do our checks. So one of the customer complaints was the front cigarette lighter in the ashtray here doesn't work, and its power antenna doesn't work. So obviously you want to check the fuses first. On the wiring diagrams I found they're both controlled by fuse number 14 in this little glove box, or fuse box. So indeed, if we look up, there's power antenna, fuse 14, 20 amp. And then, let's see, glove box lights 14, cigar lighter front 14. And what do you know? Fuse 14 is missing. So that's power on one side. Let's plug in a bright, 5 amp test light. Make sure there's no short circuits on there. Ooh. I guess that's why you took it out. Well, that explains that. Power antenna is just stuck on. That's why that fuse is pulled. I wonder if you turn the radio on, will it go the other way? Maybe the limit screw's broken. Well, that's flashing. I guess we can pop in a 20 amp fuse. Nice to have for them to have spares. Oh, power. Wow. I think the antenna quit. Let's see. There it goes. Crazy again. It reverses. So something in the linkage is broken. And it just won't stop. Let's pull that out before the motor burns up. Okay, so that problem's figured out. I guess we just unplug the antenna or leave it extended if we can get it up. Alright, doing a quick visual inspection. The antenna motor lives behind the fender liner right there. And it looks like the wires go into the body right here. You see that green and white wire? They come to this relay. So what I'm going to do is just unplug this, disable the motor, but we should still have reception at the radio. So let me pop in the fuse and we'll see what happens. By the way, the antenna extended a little bit, so I pulled it up to here. You can manually move it up and down, not a problem. Alright, so fuse is in, motor is not running, relay didn't click or anything. Let's wow, that is some nice bass. Nice reception. Let's scan it. Oh man, the owner is going to be so pleased with that. And then the clock stays on, won't lose memory. And last but not least, let's check the cigarette lighter. So I had my snap-on adapter plugged in here. Let's put this back. Look at the attention to detail here, people. This is just simply beautiful. Back when they cared, instead of saving pennies, they actually delivered a product people would want to buy and be proud to own. What a concept. Let's get this thing. Let's see if we have power on our cigarette lighter up front. Yes, we do. We have the green LED. And then we can set the clock. Whatever the... Let's see if we hold this and push something. I'm not sure how to set the clock. But everything works and the antenna's up and we have reception, so that's a win. So we have some headlight problems. The low beam does not work and neither does the marker light. Probably just burnt out bulbs. This one looks kind of foggy, like moisture got in there. So I don't think we need instructions how to take this off. Just 4 screws for the bezel. And then 1. Take off this trim ring. Okay, and then I assume it just unplugs. I guess you just have to buy the whole damn thing. When was the last time you replaced a sealed beam headlight? Alright, drive belts. So for the AC, this is an old R12 system. And the compressor, if you turn it by hand, it's really sticky. So what I'm going to do is just unplug the clutch. I zip tied all the harnesses because in typical GM fashion they've already been rubbing on metal parts. So we don't want that. And the belt is loose, the compressor is crooked, but we don't care whatsoever. We're just going to leave that alone. The power steering, we do need to tension, and unlike Japanese car makers like Toyota, Honda, make everything very, they think things through, so it's easy to service things like drive belts. GM, not so. To tension this power steering pump, we need to undo these 2 nuts way down here under the alternator. 15 millimeter. Then there's one on the back that requires a swivel extension and a swivel socket, like a ball socket, because it's right next to the exhaust manifold. So I got that cracked loose. What a pain in the balls. So now the power steering pump should be able to move. We want to, I'm guessing, lift that up to tension it. Okay, so down is definitely detension. Let's try to lift it up. Alright, so power steering belt is nice and tensioned, just like the alternator belt. we were not going to touch the AC belt. I'm just going to let that slide. Now let's take off the left front wheel, inspect that brake. Alright, we're jacked up in the air. This tire spins very freely, but the left front, not so much. Definitely dragging. So let's pop it off, take a look at those brakes. So center cap is off. What the heck is this? Push clip in this direction to remove lock nut. I guess there's a special lock nut wrench. I have to go in the trunk and look for that. So weird. Sure enough, here it is in the trunk right on the spare tire. That's pretty cool. It gives you instructions. Never seen this before, ever. There we go. Alright, now we got some lug nuts. I'm loving this REVVSTARK impact wrench. It's compact, light, it's loud, but it's efficient. Perfect. 14-inch wheels. How about that? So the caliper bolts are a Torx 50. That was easier than expected. Alright, let's pry this sucker off of here. The rotor isn't even seized to the hub, which is really impressive. Go. Beautiful. Alright, now we've got to work with the piston. So we'll remove the pads. That one is there. So the pads are still in good shape, even though they were rubbing and rubbing and rubbing. Okay, now let's push the brake pedal, see if the piston comes out, see if it's all rusty inside, and see how it retracts. So let's do that. Okay, it's coming out. So the piston retracts pretty nicely just with some grips from the side. That's what you're looking for. Let's make sure it goes all the way in. Okay, good. We exercise that a couple more times. We'll lube the pads and put those back together. So great news, the piston looks mint under the rubber, no signs of rust. So let's push it back in and just lube everything up. Alright, so the caliper is sliding nicely on the pins. Should probably put that boot back on a little more securely. Bottom one is happy. Let's push the brake and see how this thing works. Alright, let's push the brake pedal hard a few times and then see if that piston retracts normally. Nice pressure. Yes, turns freely. Awesome. So we're done. Let's put the wheel back on. Then we'll be ready to do the fun stuff, actual diagnostics. So on the scanner, just for kicks, I tried logging in as an 86 Oldsmobile 98 instead of an 85. And check it out, we have more data that we can use, like the TPS. I wanted to check that. Just a nice slow sweep down to the floor. Maxed out at 4.42 and back down. Then we have integrator and block learn. So I don't know if those two will be active in 86, but let's just start up and see what happens on the live data here. Alright, look, IAC is dropping to basically 0. We're still at 1100 RPM. It's shaky, so there could be a vacuum leak at like an injector seal, causing a single cylinder misfire. It's going rich and lean. Integrator 103, 105. So I don't know if block learn will actually do anything. Then we have our oxygen sensor. It's in closed loop. Coolant temp is showing properly, so I like this data list. Let's pull it back in the shop and put a smoke machine on the intake and see if there's some obvious problem like an injector O-ring that's missing. I really want to get this idle down so it's nice and happy and smooth. Alright, so let's check for vacuum leaks. I got the intake pipe plugged off, and we're sending in smoke through the PCV inlet into the intake manifold. So let's turn on the machine. I can hear a hiss already. A little bit coming out of the oil dipstick, a little bit coming out of the throttle shaft. There's some coming out of the transmission. How is it coming out of the transmission? I mean, there's a vacuum line going to the transmission. What about the brake booster? Most of the hiss I hear in there. Can we pinch off a hose somewhere? It's all solid metal line. Let me try to pop that off. Well, I took off this line. If I plug it off, it's still coming from the bell housing. Is that like a rear main seal? This doesn't make any sense to me. How can, is it leaking past, through an intake valve into the crankcase? Why is it coming out of the bell housing though? There shouldn't be any source of passageway from the crankcase down there, should there? I don't think so. Okay, so I took this line out of the crankcase cover and just plugged it off. That's the breather fresh air intake for the crankcase ventilation system. We have a little bit of leakage at the EGR, which I guess it's normal along the shaft there. Now where's it going? Still going a little bit into the crankcase, a little bit out of the throttle shaft. EGR valve is leaking, it would be coming out of the tailpipe. I don't think it's an EGR problem. Nope. Oh, what a mystery. By the way, I do see some new parts. Idle air control valve fuel pressure regulator. I think they were trying to get this car to run decent so they could sell it, and they never really did. There's the aftermarket mass airflow sensor. I mean, I guess it's a hot film design with a honeycomb. There's a US patent number. Flow is that way. So, I don't know. Let's put it back together and take it for a spin. So next day, back to the 1985 Oldsmobile 98 V6. I talked to the customer, gave him the lowdown on all of the things we did and what's left to do. So for drivability, there are two separate issues here. The rough idle kind of feels like a single cylinder misfire, and the high idle speed that the IAC can't bring down, and the smoke machine test where there's a lot of smoke coming out of the crankcase. Put those three things together, what's the only thing that can cause that? A faulty gasket between the intake manifold and the valley. We've seen this before on a 98 Chevy truck, 5.7 V8, where the intake manifold gasket was breached and was creating a vacuum leak, putting high vacuum on the crankcase, causing a partial miss on a cylinder and basically, creating drivability problems. I think the exact same thing is happening with this car. It only has 5,000 miles, but if it sat for 30 years and the coolant got old or whatever, that gasket is, it's time to replace it. It's this big valley gasket. It's not two separate, one gasket per bank. It's a big gasket that goes all the way across the whole valley. So, customer agreed to that, but that does not explain this severe loss of power under more than half throttle. That's what we're going to diagnose right now. So get out some popcorn. Let's do this. So for this diagnosis, we're going to use two of my favorite indispensable tools, the 4-channel Pico scope and the Snap-on Veris with live data. So for live data, I'm looking at 10 data PIDs: RPM, integrator, TPS, IAC position, coolant temp, oxygen sensor, open loop, closed loop, block learn, airflow, and NOx sensor. Okay? So by the symptoms, what could cause this? You could say, is it a restricted intake or exhaust path? Well, I don't think so. It's more like a switch. As soon as you hit that threshold, someone flips a switch and the car starts decelerating. It's not a build up to where it's running poorly. It runs great, really smooth, and then boom, shut off. And you let go of the throttle a little bit, then it starts pulling again. So it has to be something electrical. Fuel delivery or spark timing are the two big variables here. So on the Pico scope, we're using all 4 channels. Here's what I want to measure. So I printed out the diagram of the pinouts at the PCM. So channel 1, I want to measure the TPS signal so we know a correlation between your driver desired input and what's going to happen. Mass airflow sensor is on channel 2. Channel 3, I want to measure the injector driver for bank 1, cylinders 1, 3, and 5. So here we have 6 injectors obviously, and it looks like they have 2 separate drivers. So the driver for this one actually comes in on 2 wires, probably to carry more current. For cylinders 2, 4, and 6 is bank 2, and then 1, 3, and 5 comes in on another pair of wires. So I want to measure just the voltage on bank 1, it's a light blue wire, and then injector current on this bundle of wires. All 4 wires I want to measure the entire injector current for all 6 injectors. Now, I don't know the strategy. They're either batch fired or group fired. It could be one big driver just grounding all 4 wires once per, every 2 engine revolutions. So that's the amp clamp. Let's turn it on. and you want to make sure that your scope is rolling, make sure the amp clamp is working. Look, that's the mass airflow sensor signal. It's actually a frequency, so I don't know if that's going to be too useful. Yeah, we could do a math channel frequency of B after we collect the data. You know, that's fine. We could do that. But the current clamp, once I turn it on, you should see a little blip on the yellow trace. There it goes, and I'll re-zero it. And now we're ready to roll. So these early fuel injectors, GM fuel injectors, they're known to short out, and we have a mixed bag of injectors. There's like 4 replacements. One might be original, one might be aftermarket, or whatever. I want to see under high flow, as it's drawing more and more current, is something overloading the PCM and it's cutting the injector pulse or something. On one bank, the engine could still run at half power kind of smoothly. That's a possibility. I want to rule that out, or if we see something interesting, we'll explore that further. So that's the initial test drive. We're going to collect this data and look at the scanner and see where this goes. Alright, here we go. Let's restart the scope. Okay, a little bit of a long crank, but looks like it's running smoothly. I should flip my current clamp around. Let's back out. Yep, it's staying running. It's obviously shaking due to that vacuum leak. IAC position is coming down, the RPMs are coming down. We're in open loop, running, just fine. It's rich. Let's let it warm up a little bit. So on the exhaust pipe, partial miss on one cylinder. That's where the gasket's messed up. Seems to be running pretty good. Okay, I got my amp clamp turned around. Let's change the scale on that. And so it looks like it's a batch fired system. So all 6 injectors are firing here, and the let's see if we put the cursor right here, about 3 amps for all 6 injectors. So about half an amp a piece. I think that's reasonable, and it's just pull down and let go. There's no kind of switch and hold. This is just classic layout. Okay, so I like that. We don't see any shorted injectors right off the bat. So we'll do 1-2 second time base. Let's rev it up. Seems to run pretty well. Block learn and integrator are very happy, close to 125 or 128. Closed loop. Everything's looking pretty good. Look at the knock data pit, 49. What does that mean? Now keep in mind, this list is for 86, not 85. Let's take it for a test drive and see if we see anything interesting. Okay, so I did, just from a stop, a hard acceleration, and I hit that zone where it was kind of like losing power and bucking, and then I let off the gas. Do we see anything interesting at all? On the mass airflow sensor, I actually graphed the frequency right here. That's the black, and it goes up to 150 hertz. So if we translate this into frequency, 150 hertz. Nothing wrong with that. Nice and smooth, and there's the TPS, so it follows the throttle. Anything interesting going on with our injectors? No dropouts, no shorting, no overcurrent. The fuel is delivered, no problems. No problems at all. You might ask, is this a fuel starvation problem? Well, it can be because the oxygen sensor stays rich. We can see that in the data. We'll do that acceleration one more time. So right now it's oscillating. Let's look at TPS, airflow, and oxygen sensor. Do this acceleration one more time. So nice and smooth. Floor it. Okay. So max 150. Like that. TPS was there. You can zoom in a little bit. Is it too much gas? Is the mass airflow sensor over-reporting? Let's also look at our integrator. So we're just cruising around. We're at 120. Everything's really happy. 116, 110. Keep the oxygen sensor oscillating. Is this thing just injecting way too much fuel? That's my question. It ran a little better with the mass airflow unplugged, but still, it wasn't happy because it needs to know how much air the engine is consuming. So as we get into the throttle, the integrator is just peg low at 100. That's like minus 30%. And our oxygen sensor is rich. If we really start getting into the throttle, look what happens to the oxygen sensor. It goes richer, 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 0.9. Oh, right there, it's just too rich, 0.92. Okay, so that's it. The diagnosis is done. This mass airflow sensor is over-reporting. It's just skewed. The more air flows through there, the more it's over-reporting. It's going up to almost 150 grams per second, not even at full throttle. So that's it. There's a blown intake gasket and aftermarket mass airflow sensor for this Oldsmobile. Where are we going to find an OEM replacement? We can try other aftermarket ones, eBay, but no big issues here. Just a couple small things causing kind of an annoying drivability problem. But otherwise, it seems to drive pretty well. It's just, once the fuel trims run out of room to compensate, then obviously it's running too rich. We just proved that. The oxygen sensor is at 0.9. and then it starts following spark plugs and whatever. Like right now, even now it has a little hesitation. I'm sure the fuel economy is not great either. Now we're back to an idle. Now keep in mind the intake gasket's leaking, so a little bit of air is getting around the mass airflow sensor. And here, integrator's pretty close to happy. Block learn's like minus 10%. It's still taking fuel away. So this mass airflow sensor is over-reporting across the board, but under high airflow, it's even more skewed, and the fuel trims can't keep up. So when it's in closed loop, you should see the oxygen sensor going up and down all the time, unless you're maybe wide open throttle. Then it might show open loop there. So that's it. Pretty cool scope captures. Nothing wrong with injectors. Now, is it possible that these aftermarket injectors are flowing a little too much? That's a possibility. So we have aftermarket mass airflow sensor and aftermarket injectors. But, let's say the injectors are flowing too much. That would be more of a continuous, or not continuous. It would be the same air across the board. So at idle, they would flow 10% more. Under wide open throttle, they would flow 10% more. So your fuel trim would always be the same, no matter where you are in the load range. Mass airflow sensor that's skewed, it can do weird things. It could be pretty close at idle, a little rich, and then under heavy load, it's so bad that the engine can't keep running. It's way over fueling. So we'll go online, see if we can find some parts. Well, looking on eBay, here's a part number, 25007539. Check this out. We have some options. 28 bucks, 35 bucks, 45 bucks, 60 bucks. There it is. That's our mass airflow sensor. Made in the USA. Buy it now. Last one. In Connecticut. Alright, we're going to get it. Alright, let's take some data on these fuel injectors, analyze it. And some people ask me, why do I stick with Pico Scope 6? I have tried 7 several times, and I keep coming back to 6. Why? Several reasons. So Pico Scope 7 takes up a lot of room on your computer, like almost 2 gigs. Pico Scope 6 takes up 500 megabytes. That's one reason. That's not the main one. Second reason is, on Pico Scope 7, you cannot make custom probes with custom ranges, like I have for my pressure transducer. A lot of people have been asking, when they order the transducer, do you have custom scales for Pico Scope 7? I tried making them. Can't do it. It's too primitive. It does not have the same functionality as Pico Scope 6. So there's some feedback for Pico. If you want people to use 7, make it at least as good as 6 with the same features. The layout, I don't really care for all the buttons taking up the room on the screen. I want simplicity, speed, efficiency, and capability. That's why I'm sticking with Pico Scope 6. But anyways, let's zoom in. So here we're at idle, then we step on the gas and accelerate. So at idle, now it's a high idle. You can measure the RPMs, just put 2 cursors on neighboring pulses. And does that make sense? 1200 RPM? Yes, that's exactly where we were idling. So first thing we can say is these injectors, they're fired all at the same time, once per full combustion cycle of one cylinder. So for every 2 revolutions of the crank, well, they're fired twice for once per revolution of the crank, right? So if this is 1200 RPM, boom, boom, they fire once per crank revolution. So twice for one camshaft revolution. And how do I know that? well, the voltage trace was on just bank 1 injectors, and you can see, and the current clamp was on all 4 wires for all 6 injectors. So they're occurring at exactly the same time. If it was batch fired, like bank to bank, we'd have twice as many current pulses as bank 1 pulses. So this is a group fired system, first year for fuel injection, so that's to be expected. Now let's focus on the pulse width. About 3.3 milliseconds. So I'm going to write that down. 1200 RPM, 3.3 milliseconds at idle. Let's zoom out where we revved up and then it started bucking and carrying on here. So this is a higher RPM. Let's measure the pulse width here. First, let's measure the RPM. So 2600 RPM. And the pulse width is actually pretty fat. It's taking up almost the entire space here. About 17 milliseconds. So 17 milliseconds at 2600 RPM, and this is too much. Here it's in fuel control. Here the oxygen sensor is pegged high. The integrators were, down as far as they could go. The frequency on our mass airflow is 155 hertz. So we can write that down. MAF. Here it was 155. And at idle, let's bring cursor number 1 over here. About 65 hertz, from 65 to 155. Okay, I'll write that down. So when we get a replacement mass airflow sensor, whichever one it is, we can easily reproduce this and say, at this frequency it's making this pulse width for the for the fuel injectors. So that's all I want to do. Now we need some parts.